Now what is relative mass and how do we calculate it? There you can find that magnesium mass is 24 and that of chlorine is 35.5. How do we calculate reacting masses from the reaction? Okay, can I say that to produce 80 gram of magnesium oxide, 48 gram of magnesium is needed? Hello and welcome back, students. This is going to be your fourth lecture on topic stoichiometry. And if you haven't watched out the first, second and third video, then go check them out. They are going to be very helpful. And if you haven't been following us till now, then please watch the videos. And if you like the videos, then show your appreciation by liking the video, sharing it with your friends and family, and subscribing to our channel. So let's quickly begin. So before we dive into this video, let's first understand what all topics are we going to talk about. So first we are going to find out how do we calculate empirical formula if the percentages of elements are given to you in any formula, right? Next, then we will try to understand or try to calculate how to find out mass percent. So let's quickly dive into it. So the first topic is going to be like how do we calculate the empirical formula? Okay, so empirical formula is the simplest ratio of molecular formula, which we have already discussed in your first lecture, right? Now let's discuss how do we calculate empirical formula. So a question is given to you, a sample of antifreeze has the composition by mass, carbon, hydrogen and oxygen elements are given to you, the percentages of each one of them is given. So let's quickly write one by one, carbon, hydrogen and oxygen. Okay, the percentages which are given is 38.7, 9.7, 51.6. You can simply neglect the percentage sign. Okay, you can neglect this sign. Now let's check. So we are understanding how do we calculate empirical formula by doing a question. Okay, so there's no theory in this, just calculation and questions. So A part, calculate the empirical formula. Now how do I calculate if the percentages is given to me? So let's check. The step 1 will be, we have to divide the given percentages or grams, it can be given in grams also, we have to divide this by the atomic mass of these elements. Okay, so the atomic mass of carbon is 12, so I'll divide this by 12. The atomic mass of hydrogen is 1, so I'll divide this by 1. Then oxygen is 16. Okay, let's find out the answer of each one of them. This is step 1. So how do I do? 38.7 divided by 12, and this will give you 3.225, right? Next is 9.7. So this will remain 9.7 because dividing anything by 1 will give you the same number. 51.6, 51.6 divided by 16. So this will give you again the same 3.225. Okay, this was the step 1. Now step 2, let me change the color. Step 2. In step 2, what we are going to do, the smallest answer which we have got in the step 1, we are going to divide all of these by that. Okay, so the smallest number is 3.225, right? So we'll divide everything, like all the carbon, hydrogen and oxygen by this number. Okay, 3.225 divided by 3.225. This is your second step. Now let's find out. This will give you 1. This will give you, if you divide 9.7 from 3.225, this will give you 3. Okay, this will give you 3. And if you will divide this, you will get 1. Okay, so this is now the simplest ratio in which carbon, hydrogen and oxygen is present. Okay, so I can write my empirical formula to be CH3O. I hope this is clear. This is the simplest ratio which we have found out. Okay, simplest ratio, right? So CH3O is going to be your empirical formula for this antifreeze, right? One part of the question done, A part is done. Now let's move on to your B part. So I am doing the B part here. Let me change the color of the pen. Let me take orange. Okay, so B. In B part, what are they saying? The relative molecular mass of the formula compound is 62. Okay, so it is given that the mass of compound is 62. What is the molecular formula? Now we have to find out the molecular formula. Empirical formula is already done. We have to calculate the molecular formula. The mass is given to you. The molecular mass is given to you, which is 62. Now let's first find out the mass of empirical formula. Okay, so how many carbon atom? 1, so 12 plus 3 hydrogen means 3 plus 3 plus 1 oxygen means mass or atomic mass of one oxygen atom is 16, so 6, right? If you solve this, you will get 31. Okay, you will solve this, you will get 31. Now observe the masses. The empirical formula have mass 31 and the molecular mass have the mass 62. So it is just double of it. So what if I twice the empirical formula? I will get my molecular formula, right? If I twice this empirical formula CH3O, like I simply multiplied this by CH3O, I will get C2H6O2, right? So your molecular formula MF, I am writing molecular formula, will be twice of empirical formula here because the molecular mass is twice. So twice of empirical formula means CH3O, which will be equivalent to C2H6O2, right? So this should be my molecular formula. Now to verify that if my molecular formula, which I have found out, is correct or not, let's find out the molecular mass of this. So 2 times 12 plus 6 plus 2 times 16, so 32 plus 6 plus 24. Okay, this will give you 62. Okay, 62, and the in the question also 62 was given as your molecular mass, hence proof. Hence we have verified that our molecular formula will be this C2H6O2, and the empirical formula, which is the simplest ratio of C2H6O2, will be CH3O. So I hope this is clear. Very easy. We have to find out the empirical formula in 2 steps. First, divide the percentages or grams which are given to you in the question by the atomic masses. Okay, then the second step is whatever is the lowest number, you simply divide all of these by the lowest number. Then you find out the simplest ratio, which is this 1:3:1. It means carbon, hydrogen and oxygen are present in 1:3:1 ratio. Okay, this will give you empirical formula. Once you have got your empirical formula, you find out the mass of empirical formula. Then you try to observe the values of the mass of empirical formula and the molecular mass which is given to you. Then you will simply understand that it is just twice of molecular mass. Hence I can just make the empirical formula twice to get molecular formula, right? This is how we are going to get your answer. This is going to be your molecular formula. The mass is this, hence verified. Now take a minute here, try to understand what we have just done. If you wish to write it down or take a screenshot, you may do so. Now let's move on. Okay, so I have one more similar type of question for you. In this question, an acid has following composition by mass: carbon 40%, hydrogen and oxygen. Now let's quickly do it in a similar way. So A part we'll do first. Carbon, hydrogen and oxygen is given, right? 40%. Previously also I asked you to neglect the percent sign. Now what was the step 1? Step 1 was to divide it by the masses, right? If you will divide it, you will get, okay, 40 divided by 12 will give you 3.33. This will give you 6.6. This will give you again 3.33, right? Now step 2, dividing by the smallest number. 3.33 is the smallest over here. This will come out to be 1:2:1, right? So I can say that carbon, hydrogen and oxygen is present in the simplest ratio of 1:2:1, right? So I can write empirical formula will come out to be CH2O. Okay, this is the empirical formula. I am writing EF, you have to write empirical formula, make sure. Okay, then let's find out the mass of empirical formula, because we will be needing it for B question or for B part. Okay, so let's quickly find out the mass of empirical formula. 12 plus 2 plus 16, right? This will give you how much? 30, right? This will come out to be 30. Now in the B part of the question, let me change the color. Now in the B part of the question, it is given that relative molecular mass is 60. So the mass of the molecular formula is 60. As you can say, 60 is just twice of 30. So I can say that if I simply to find out the molecular formula, molecular mass is given to you, molecular mass which is 60. Okay, so I just multiply 2 with empirical formula, that will give you 2 times CH2O, which will give you C2H4O2. So this is going to be your molecular formula. If you want to, or if you wish to verify your answer, simply find out the molecular mass. It should come out to be 60. So 2 times 12 plus 4 plus 16 times 2, which is 32. This will come out to be 24 plus 4 plus 32. 28 and 32, which is going to be 60. Okay, yes, hence verify 60 and 60. That molecular formula of this question which we have found out is C2H4O2. So this is the answer for your B part, and this will be your answer for your A part. You can quickly write it down. Now let's move on. Okay, now another very interesting and small topic, very easy to understand. Let's dive into it. Mass percent. Now, how do we calculate mass percent, or what is mass percent? So, the percentage by mass of each element in a compound is termed as mass percent. Okay, what does it mean? For example, if you have water, H2O molecule, and if I ask you how much of hydrogen is present in water molecule in percentage, or how much of mass percent of hydrogen is present in water, then what do? First, we need to calculate the molecular mass, okay, of water, which will come out to be 2 plus 16, oxygen is 16, so 2 plus 16 equals to 18. This is molecular mass. Now I have to calculate the percentage of hydrogen in H2O. So what do? The mass of hydrogen which is present in this molecule, which is 2 atoms of hydrogen present, means 2 times 1. So in total 2 gram of hydrogen is present in this H2O. So 2 divided by, what is the total mass of the formula? It is 18, which we have already calculated, right? The molecular mass. So 2 divided by 18 times 100. Why times 100? Because we have to find out the answer in percentage, right? So if you will solve this, 200 divided by 18, this will come out to be 11.11%. Okay. Similarly, if you wish to find out the percentage of oxygen in H2O, what do? Either you can simply find out the percentage of hydrogen and subtract that percentage from from 100, or you can also do like you can subtract 11.11 from 100 and you will get the answer for oxygen, or you can also do it like this, percentage of oxygen in H2O. So how much in grams or the mass of oxygen is present in H2O? It is 16, okay, because 1 atom of oxygen is present. So 16 divided by 18 into 100, this will give you approximately 88.88%. So this is going to be your mass percent, okay. So this is how we calculate mass percent. If we wish to calculate the percentage or the amount of percentage which is present of a particular element in that compound, then we do it like this, okay. So let me clean this. Now let's get to the question. So the question says calculate the percentage by mass of nitrogen. Okay, for nitrogen we have to calculate, this is important, the following fertilizer and nitrogen containing compounds. So two parts are given to you. So B I will do here. Let's do A over here, right? So ammonium phosphate is NH4 whole thrice PO4. This is ammonium phosphate. We have to calculate the percentage of nitrogen which is present in this ammonium phosphate. So let's first calculate the molecular mass. Molecular mass equal to, how many nitrogen do you see here? 3. So 3 times nitrogen mass is 14, right? So 3 times 14 plus how many hydrogen do you see here? 4 times 3 is 12. So 12, okay, times 1 I am not doing because hydrogen mass is 1, we know that, plus phosphorus is how much? 31, only 1 atom is present, so 31 plus 4 oxygen atom is present, okay. So 4 times oxygen, which is 16, let me do it, 4 times 16 is equal to 64, okay. Now we'll simply calculate this, 42 plus 12, okay, 42 plus 12 plus 31 plus 64, and that will give you 149. 149 will be the molecular mass of this ammonium phosphate. All right, this is going to be the mass of ammonium phosphate. You can write in grams, or you can also use U, okay, U or unit, right? Next, we have to calculate percentage of nitrogen. I am writing nitrogen as N in NH4 whole thrice PO4. So what do we do? How many nitrogen atoms can you see here? 3. Okay, so 3 times 14, 3 times 14 will be 42 divided by, so total mass of nitrogen, because we are finding mass percent for nitrogen, total mass of nitrogen divided by the molecular mass of the compound, which is 149 times 100. Why times 100? Because we are wanting our answer to be in percentage. Okay, so let's calculate 4200 divided by 149, which will come out to be 28.18. 28.18% of nitrogen is present in ammonium phosphate. Okay, so 28.18%, this is the answer of nitrogen will be present in ammonium phosphate. I hope this is clear. B part, if you wish to try on your own, well and good. Please, you can pause here and try this question yourself, and you can write down the answer in the comments. If you have any problem, we'll solve this again. So B is glycine. We have to find the percentage of nitrogen. So let's first write down CH2, NH2, COOH. Okay, it's an acid. So now how do we find out the mass of glycine? How many carbon do you see? 1 and 2. So 2 times 12 plus how many hydrogen? 2 plus 2, 4 and 5. 5. Okay, because 5 times 1 is 5. So I am not mentioning that. How many nitrogen? Only 1 nitrogen. So 14 plus how many oxygen? 2 times 16, which is 32. Okay, 2 nitrogen present. So 2 times 16 is 32. Now let's quickly solve this. 24 plus 5 plus 14 plus 32, which will give you 75. Okay, so this will be equal to 75. Now we have to, this is the molecular mass. Okay, this is the molecular mass. Now we have to calculate the percentage of nitrogen in glycine. So how much of mass of nitrogen is present in glycine? Only 1 nitrogen I can see. So 14 divided by total mass, which is 75, times 100. If you will solve this, 1400 divided by 75, that will give you 18.66%. Okay, so 18.66% of nitrogen is present in glycine. Now take a minute here, quickly write this thing down. I hope you have noted this thing down. Now let's try one more question. So the question says calculate the percentage mass of water in crystals of hydrated sodium carbonate Na2CO3 0.10 H2O. Okay, so sodium carbonate is given to you, sodium carbonate decahydrate. So we have to calculate the percentage of water crystal, right? So for this, first let's find out the molecular mass of Na2CO3. So Na2CO3 0.10 H2O. How do we calculate the molecular mass? 2 sodium atoms are present, so 2 times 23. Masses will be given to you. Again, I am repeating, the data will be given to you. You don't need to mug up anything. The periodic table will be provided. Plus how many carbon? 1. So 1 times 12. Plus how many oxygen? 3. So 3 times 16. 3 times 16. And how many H2O? 10. So plus 10 times 18. Why 18? Because molecular mass of H2O is 2 plus 16, which is 18. Okay, so from here I am writing the data. Now let's calculate 46 plus 12, 48 plus 180. I have my calculator with me right here. Plus 12 plus 48 plus 180. This will give you 286. Okay, this is going to be 286. So 286 is the molecular mass of sodium carbonate decahydrate. We have to calculate the percentage of water crystals. So I am changing the color. Okay, so percentage of water crystal. How many water molecules do you see here? 10. So 10 times 18 is 180. 180 divided by 286, which is total mass of the whole compound, times 100. This will give you the percentage. So 180 divided by 286 times 100. This will give you 62.93%. 62.93%, or you can also write it as 63%. Right? So quickly take a minute and note this thing down. I hope you have noted this thing down. So here we come to an end of your lecture 4 of stoichiometry. I hope this was helpful for you, and we'll meet in the 5th part of your stoichiometry. Till then, keep learning and enjoy. Thanks for watching, and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.